G. So what I would do here is integrate what I can integrate. All right, this one would become 1/4 x. The next one would become 1/4. Is it 1/4? Yeah, we got to divide. Yeah, so 1/4 sine 2x. That's where a little baby u substitution might come into play. But what we said was take a stab at it. I know the antiderivative of cosine is sine, so let's just suppose that the antiderivative was just a sine of 2x. Well, if I took the derivative of that, I would get 2 cosine 2x, which is not what I want. I want 1/2. How do I make it 2 into 1/2? Divided by 4. Right? So you can kind of do the u sub on the fly, or you could let u equal 2x and go from there. But separately, I need to find the antiderivative of this one. So I want to use the power reduction technique that I did earlier. Cosine squared is the same as 1 plus cosine 2x over 2. So I'll put the 1/4 outside. This part would become 1 plus cosine. Normally, it would, if this were an x, this would be 2x. So 2 times whatever this x is. So it's really 2 times 2x. Which cleans. We can make this 1/8 times the integral of 1 plus cosine 4x dx. I can run through with the 1/8 if I want, or I could just leave it outside and integrate this guy. So that would become x plus 1/4 sine of 4x plus c. And I'd just bring down all the other stuff. And so that's a way of representing your antiderivative. You could simplify this further, but I don't think I'm that terrible of a person that if you got to this step and you didn't simplify it further, that I would go looking to take off credit. If you got to this step, that's an achievement enough as it is. So I would call it a day at this point. But yeah, if I distributed the 1/8, I can combine some like terms. But I don't think that's overly necessary. Okay, so.